Object-oriented design with communication diagrams. In the previous video, you learned about communication diagrams and how they are used for use case realization. In this video, we will explain the steps that developers follow to develop a communication diagram for a use case. The design steps that are followed are the same for either type of interaction diagram, either a communication diagram or a sequence diagram. In this example, we follow this process using a communication diagram, but we could just as easily have used a sequence diagram. Here is the design process flowchart that we have seen before. In this video, we will be examining the design process using a communication diagram. At this point in the flow, we will already have developed the first cut design class diagram. Here is the figure that we have seen before, which shows the other analysis models that can be used for detailed design. Note that besides the design class diagram, we also will have access to use case descriptions, system sequence diagrams, and possibly activity diagrams. The use case we will work with is the Create Customer Account use case. This is the one we just reviewed in the previous video. Here is the first cut design class diagram that we developed for this use case. For this use case, we decided that we needed a customer handler class, the customer class, the address class, and the account class. We assumed visibility from the customer handler to customer, and from customer to both of its dependent classes of address and account. This is the system sequence diagram that we developed earlier during analysis. As we worked with the user, we discovered that there were 3 input messages that would be necessary to carry out this use case. The first message is one to create the customer object and is named Create New Customer. This input message has a return message with the detailed customer parameters. The second message is used to enter address information. The asterisk on the message name means that this message is a repeating message and may be sent multiple times. This message also returns the details of what was added, but it shows the return values on the same input message. Remember, this is an alternative technique to show return values. The third message is used to enter credit card information. The message name is Enter Credit Card. It also shows a return message with the same credit card information being returned. We should note a couple of important points. First, this is an analysis model and does not necessarily need to be exactly like the design model. It is used as input, but the designer does have flexibility to modify it or to change some of the names as she does the actual design. Second, even though the designer might enhance or modify the names and elements during design, it is extremely important that the analysis model be as complete and accurate as possible. The development of an interaction diagram, either a communication diagram or a sequence diagram, is the same and requires only 3 steps. First, using the first cut design class diagram, transfer the classes to the communication diagram as objects using object notation. Second, take each input message one at a time from the system sequence diagram. Your objective is to determine all of the steps, including all of the internal messages to the selected objects, to completely process this input message. As we add more messages, we ensure that the objects have appropriate visibility to send the messages. We also consider the principles of good design that were covered in a previous video. And third, give each message an appropriate name and add the necessary parameters and guards. Usually we try to name the message with a verb phrase that indicates the requested service from the destination object. We have to decide whether to show any return data as a return value or as a return message. In this diagram, we extend the first input message to all the required objects. The input message is Create New Customer. It is the first input message and we give it the number 1 and show it from the actor to the controller object. It contains 4 parameters. There is no guard condition required. This message is then forwarded to the customer object in the same form as it was received. Since this is a create message, in actuality there is no visibility yet. But we did want the customer handler to have visibility to the customer object, so we do need to return a reference to the object to the customer handler. To do this, we first add an object identifier to the object name, which we call A-C. Then that reference is returned to the controller to provide visibility. We might ask why customer handler needs visibility to customer. Well, it will have to send the other two messages to the right object, so it needs visibility to that object. Even though we are doing design, we are thinking in terms of what the programmer will need. Finally, with message 1.2, we show the detailed attributes contained in the customer object all the way back to the clerk actor. Sometimes we will leave this last message off until we add the view layer. Next, we extend the second input message, enter address. The process is the same. We give it the number 2 and send it from the clerk to the controller. Then the controller needs to decide what to do with this message. There are two choices. It could either send it to the customer object and let it handle it, or it could send a create message directly to the address object itself. However, since we want the customer to have visibility to its addresses, if the controller creates the address objects, then we would have to add more messages to provide this visibility. It appears the best solution is to let the customer handle this message. So, customer receives message 2.1, enter address, in the same form as it was received by the controller. But it forwards a create address message to the address class to instantiate a new object. This is message 2.2. Notice that it sends all the input fields. It also sends a copy of its own key field, account number. The new address object will keep account number and use it as a foreign key when it writes itself out to the database. This is an optional addition. If we did not add it during design, the program would add it later. Message 2.2 returns a reference to the new address object called add. Returning this value gives the customer object visibility to the address object. In messages 2.3 and 2.4, the data within the address object is returned first to the controller and then passed all the way back to the clerk actor. As before, we may include this message here, or we may wait until we add the view layer to show this final display. Message 3 follows the same format as message 2. It comes from the controller to the customer object, which sends a create message to the account class. The newly instantiated account object returns a reference to itself to provide visibility. This diagram is the complete design of the use case create customer account. Probably the first thing you notice is that this diagram appears quite cluttered with all the messages. This level of complexity is about as far as we can go with the communication diagram. More complex use cases are difficult to design with communication diagrams. When a person first looks at a communication diagram such as this, she might be intimidated because it looks so complicated. However, because we have walked through each input message and its related detail messages one at a time, we realize that it really is not that complex. We just need to follow each input message one at a time through its sequence of messages to understand the processing. Let's talk a minute about principles of good design. Object responsibility says that each object should be responsible for creating itself. It should also take responsibility for its subordinate or dependent objects. We have done that. All the objects created themselves. The customer object has taken responsibility for its two dependent objects. The controller has responsibility to send messages to correct objects. For this use case, that was an easy decision. Just send everything to customer. Coupling says that objects should have limited connectivity to each other. This maintains that the customer handler is only connected to the customer object. The customer object is only connected to its dependent objects, and they are not connected to each other nor to the controller. Cohesion says that objects should focus only on their own responsibility. All of these classes are cohesive. This design is a good solid design and will result in effective and efficient code.